Today's keyword is acceleration. First, we will go over the origin of the word, then we give some examples and the definition, and then we will discuss practical applications of acceleration. Acceleration is very important in physics class, and we'll be using it for the rest of the course itself. It is a word that you will come across in everyday life as well. Acceleration has 5 syllables. It is pronounced ac, cell, a, shun. When we analyze new words, we first look to see if there is a base word. Then we search for prefixes and suffixes. Does this word, acceleration, have a base word? It actually does, but it's not an English word. In this case, celer, the base, is Latin, and it means swift or being fast. This word also has a prefix, ac. This prefix means becoming, or is about to be. Ac and celer, acceler, together means becoming fast. This word also has the suffix shun. Shun, on the end of the word, means it is currently doing something. So, acceleration together is when something is currently becoming fast. The word accelerate is the verb, which just means to speed up or become faster. The opposite of acceleration is deceleration, because of the prefix de, which means to lose. In this case, deceleration means something that is in the act of losing swiftness. Acceleration happens all over the place in our lives. You come to school every day in either the bus or a car. Every time the bus stops to pick up students, it has to decelerate to slow down. To start moving again, it has to accelerate or become fast. Acceleration is the amount of change in something's velocity in a certain amount of time. So anytime something is changing, either its speed or direction, it is accelerating. This car in the picture is accelerating or gaining speed so quickly that the front of the car is picked up off the ground. Let's pause now and answer the following question. What is acceleration? Acceleration is the rate something is changing its velocity. You probably know acceleration very well, but just don't realize it yet. Have you ever gone down a slide? When you let go of the sides to slide down, you accelerate down the slide. Also, every time you drop something, it falls to the ground, just like this apple falling from a tree. When it falls off the tree, it speeds up and is accelerated towards the ground. Sir Isaac Newton also saw apples fall from trees. He thought that if it happens to a tree, then this same thing should happen to things that are taller than trees too. Newton thought that the pull of gravity could go all the way to the moon. This is why the moon stays around the Earth. Since acceleration is the change in velocity in a certain amount of time, it can be written mathematically as the change in velocity divided by the change in time. This can also be written as the velocity it has at the end minus the velocity it has at the start divided by the time it took to do the movement. To find the velocity of something given an acceleration, we multiply the acceleration by the time. To get acceleration times time equals velocity. Everything on Earth is accelerated towards the ground. This has a certain value that is almost the same everywhere for Earth. Earth's acceleration is 9.8 meters per second, or about 10. This means that after 1 second, something will be moving at 10 meters per second if you drop it. After 2 seconds, it will be moving at about 20 meters per second. We can also slow down gravity by having things fall down ramps, just like you sliding down a slide. Things that roll down a steep ramp are faster, so steep ramps are fast, and things that go down a shallow ramp are slower. Shallow ramps have things fall slowly down them. Let's pause for a second to answer the following question. What is acceleration? Also, let's pause and answer the following question. How do ramps affect acceleration?